All right. So in the previous video, we looked at numbers 7 through 10, where we used approximations using graphs. This time, what we're going to do with 11 through 14 is use approximations using a table of values of the actual function of 1/4 x squared. So now we're actually going to find the actual approximation values from our guesstimation that we did for 7 through 10. Now, for number 11, we want to use a left Riemann sum. And using a left Riemann sum, we are going to look at my x value from the left. So I'm starting from my x value from the left. And I want 6 subintervals. So I have one subinterval here, 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 and here. And notice how each of my subinterval is 1. So lucky for us, what we could do is just factor out a 1 from everything and then add my heights. Now, remember that since this is a left Riemann sum, I'm starting at whatever my height is in terms of x is equal to 0, which was 0 here. So I'm starting at 0. Likewise, at 1 here, my height was 0.25. Now, at 2, my height was 1, 2.25, 4, 6.25. The only thing that we did not take into account was 6, 9, because we stopped at 5 here. So what we're going to do is go ahead and add this up. And this is going to give me my approximation using a left Riemann sum. In this case, if I were to do that, that's going to be 13.75. Now, on the AP exam, they will give you credit for this. So just leave it like this and call it a day. For number 12, we're going to use a right Riemann sum using 6 subintervals. So once again, my subintervals are going to be the distance between my x values. That's just going to be 1. And remember, with a right Riemann sum, we started with my rightmost value. In this case, we're starting off with 9. So now we have 1. We're starting off 9, then 6.25, then 4, then 2.25, then 1, then 0.25. The only thing that we didn't take into account was the 0. So we don't want her. If I add her up, I'm going to get 22.75. All right, number 13 is going to be a little bit different from what we had for number 9. And the reason why is because if I wanted to find a midpoint Riemann sum with this, I need to approximate 1/2, 1.5, 2.5, 3.5, 4.5, and 5.5. But instead, what we're going to do is approximate using 3 subintervals. So using 3 subintervals of equal value, I'm going to have something from 0 to 2. That might be one interval. From 2 to 4 is another interval. And then from 4 to 6 is another interval. Thinking about that, this tells me that my horizontal distance between my x values are going to be 2. Also thinking about that, if I were to look at this here, let's say that I were to go from 0 to 2, I'm going to have 1 as my midpoint. Since I have 1 as my midpoint, I'm going to choose 0.25, 2.25, and 6.25 as my heights. So then I have 2.25, 2.25, 6.25, and if I were to simplify that, I'm going to get 17.5. All right, number 14 says use the trapezoid rule with 6 subintervals. So once again, we're going to have my subintervals here. And that right here is going to represent my height of my trapezoid here. So my height, 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 height. Well, to get my bases, notice how my bases are going to be the actual heights or the y values of my coordinates here. So my trapezoid, I'm going to have 1/2 height, base 1 plus base 2. Notice how you have a common height of 1 and a common 1/2. So I'm just going to take that out. And then I'm just going to go ahead and add 0 and 0.25 to represent my first trapezoid. Then a 0.25 and 1 to represent my second trapezoid. Then 1 and 2.25 to represent my third trapezoid. And then 2.25 and 4 to represent my next set of trapezoid. See, that's 1, 2, 3, 4. My fifth set is going to be 4 and 6.25. And then my last set is going to be 6.25 and 9. Which checks out, so if I were to look at this right here, I know that I have a height of 6.25 and 9 right here, which represents my height. And then, of course, my base being 1. All right. So then, once again, on the AP exam, you do not need to simplify this. Just keep it like this and call it a day, which is what I'm going to do. All right. So let's look at number 16. And then we'll look at, let's look at 16. Based off of what we learned here, you should be able to give me definitions of a left Riemann sum, a right Riemann sum, a midpoint Riemann sum, and the trapezoid rule based off of our approximations that we did in this video and in the previous video. But now we're going to do some more practice in terms of Riemann sums. Now, notice how here our Riemann sums were kind of easy peasy lemon squeezy because my subintervals were always the same. It was always 1, 1, 1, 1, 1, 1. That might not be the case. So something like number 16 here, where I want a left Riemann sum of 4 subintervals to estimate the total amount of water removed during the 8 hours. So notice how here my height or my distance is going to be from 0 to 1 is 1. My distance from 1 to 3 is 2. 3 to 6 is 3. And then from 6 to 8 is 2. Now remember, since this is a left Riemann sum, I'm going to start at my leftmost value and then work my way down to the right. So I'm going to have 1, 1340, 2, 1190, 3, 950, and then 2, 740. And this right here is going to be my approximation for the total amount of water removed during the 8 hours. And notice how here I did not simplify anything. The AP readers actually want you guys to put it in the unsimplified form because they want you and they want you to understand where you're getting the 1 and the 1340 from, where the 2 and the 1190 comes from, where the 3 and the 950 comes from, and where the 2 and the 740 comes from. Because if you multiply this out, the AP readers won't be able to know if you understand the concept of Riemann sums. All right, so same thing with number 17 here. We're using a midpoint Riemann sum using 3 subintervals. So I have 0 to 4, 4 to 8, and then 8 to 12. Notice how my subintervals are always the same. It's going to be 4, 4, 4, so that's good. And then because I'm using a midpoint Riemann sum, I'm going to have 38, 30, and 18. We're just going to leave it like that and call it a day. All right. Number 18, same process by C's, except this time, well, it's a left Riemann sum, so I'm not going to do that because you already did that for 16. All right, in the next video, we are going to look at precise definitions of an overestimate and an underestimate based off of what we found in the previous video here. And then what happens if we have a function that is decreasing? What happens then?